In this first video segment, we are going to look at the connection between the graph of each radical equation and the solution. So what we're going to do in the calculator is take this equation and put it in for our y1. And then we're going to look at where it crosses the x-axis because that's where it would be equal to 0. So go over to the calculator, go to your y equals. You're going to plug in second x squared, square root, and then do x minus 1. And then scroll outside and put minus 1. If you're using the older version of the calculator, make sure that you use parentheses around the x minus 1 for inside the square root. Now I'm just going to hit zoom 6 so that I can see a nice graph. And I can see that the graph is going up across the axis at 2, and then it keeps going up from there. So it looks kind of like this, and would go that direction. And the solution would be that it's at 2, 0. Now for solving purposes, we'll go back to the original. You would first want to add 1 to both sides, get the radical by itself. And then we're going to square both sides at this point to get rid of the square root. So that's kind of a new step. And then finish solving. Usually the solving techniques to finish solving are not too tough, maybe not as easy as this where we're just adding 1, but two-step equation. Okay, so the solution that we're getting here matches where it crosses the x-axis on the graph. So that's going to be important when we now look at our next few examples. Okay, so our second example, slide this up a little bit, is square root of 9 minus x squared equals 0. Again, we'll just take a quick look at the graph and see what happens. So I'm going to put into my y equals, clear this out, second x squared, 9 minus x squared, and then scroll out. Everything in this one is underneath the radical, so I'll just hit graph. And I see a semicircle, and one of the pieces is hitting at -3 and one at +3. All right, so our solving technique here is right away to square both sides. The radical is all by itself, so I'll immediately go to that squaring both sides for our first step. Now, in this case, we're squaring 0, so that really doesn't do much except get rid of the radical on the left side. Subtract 9. And then here it's important that we really have this -1 in front. You want to divide by -1 on both sides before taking the square root. Now remember, when you take the square root, you get the plus or minus answer. And you see from graphing it that you had the two answers here. So you had the answer of -3, 0 and 3, 0 from graphing. So graphing is actually a great way to check if the equation is simple enough for doing that. Now this equation is going to be in a weird format just so it makes it easier to type it into the calculator. Normally, this second square root here of the negative square root of x plus 4 would be on the other side of the equal sign. But for now, and we're going to move that next time around, but for now, graphing purpose-wise, we would like to have it on that side. It just makes it easier to put it into the y equals. So again, we'll go to the calculator, clear this out. hit graph. And just like the first one, it's going through at one of the points, and it looks like it's going through 2, 0 again. So we'll do a quick sketch. The only difference is this one starts a little further back. And then now for solving, I'm going to add the square root of x plus 4 to the other side so that we get square root 2x plus 2 is equal to the square root of x plus 4. And when you have two square roots that are equal to each other, right away you can go into squaring both sides. So we get 2x plus 2 equals x plus 4. Solve that. Oops, watch out for that negative sign there. There is no negative. So we do get x equals 2, again matching up nicely with our graph. So our last one is going to have a little bit of an interesting final answer, and the graph is really going to help us see why we get this answer. Very similar to the last one that we did, where normally you wouldn't see this equation in the format that I'm showing you. So when we do go to solve it, you'll already see the other square root on the other side of the equal sign, most likely. Otherwise, you would add it to the other side for solving purposes. But let's graph it first and see what happens. In fact, I'm just going to edit this one because it's so similar. Save myself a little bit of time typing it in. So you could just change out to the 2x plus 2, change that to 2x plus 4, and then change the x plus 4 to an x plus 1 instead. Now when I hit graph on this, you'll notice it does not cross the x-axis. So let's see what that means about our solution. And it goes like that. So again, first step, when the radical is on both sides, when there's nothing else to clear out, we square both sides right away. We get 2x plus 4 equals x plus 1. Very similar solving to the last one. But when you subtract 4 from both sides, we get negative 3. Now you might be tempted to write that as your answer, but something that we're always going to recommend you do with these is checking. And it wasn't necessary yet because we were able to see on the graph that everything worked out. But you always want to check whether you do it by graphing or you plug it back into the original. So if I plug in the negative 3, and I'll plug it into the easier side, but you can plug it into both sides. If I plug in the negative 3 into the square root of x plus 1, I get the square root of negative 2, which is not a real solution. So for this, I'm going to put no solution. When we start to talk about something called an imaginary number, adding the word real in there is also important. So there's no real solution to this equation, and it doesn't cross the x-axis, so that's a good way to check it. All right, and this is our first installment. You will check out the second video to do some more solving without the graphing, but maybe as a check.